Let's look at another example here in this section of an application. Let's read, if a ball is thrown upward at 96 feet per second from the top of a building that is 100 feet high, the height of the ball can be modeled by this function, where s of t measured in feet, or is measured in feet, and t is the number of seconds after the ball is thrown. How long after the ball is thrown is the height 228 feet? Well, this function, this quadratic function, models the height where t is the number of seconds after the ball has been thrown. And so the question is, we want to find the corresponding t values to that output value of 228. So like previous, hopefully you're thinking we should replace the output variable with 228, and then we need to try to solve for t. So that looks like this equation right here, 228 equals the right side. And so what we have here is a familiar quadratic equation to solve. Again, in a few sections prior, we could use the intersect feature of our calculator. We would plug that into y1. This would create a parabola opening down, since that's a negative quadratic coefficient. This would be a horizontal line at 228, and then find out where they intersect, and then use the input value of the intersection points as answers. But we want to use the quadratic formula. In order to do that, we got to have 0 on one side, everything else on the other. So to do that, we got to subtract 228 from both sides. And if we do that, combine like terms on the right, we get 0 equals this value. And so now we're ready to use the quadratic formula. To do that, we need to recognize what our a value is. Here it's negative 16, our b is 96, and our c is negative 128. And you should write that down for yourself, so that when we plug in these values into the quadratic formula, which says in this case t, our variable that will solve this equation, can be found by this, the quadratic formula. Sorry, let me get that down there. So the idea again, here's your b value, your a is the quadratic coefficient, quadratic term coefficient, and your c here is this guy. So plugging those in and using parentheses to do so, you should always do that. Well, again, you should write those a, b, and c's down always, and then replace those values into the formula. So our t value that satisfies our equation up here is found by this calculation. So here's the technique in your calculator. Get one number underneath the square root, simplify that guy out front, and simplify the denominator. So let me show you. Let's start underneath the square root on your calculator. I'm going to plug that in with parentheses 96, and you don't need it because it's positive, but I always like to do it. Minus 4 times the negative 16 times the negative 128, and you should do this with me. So that's going to give me 1024. So 1024 is what goes under here. That's going to be a negative 96, and that's going to be a negative 32. So that's what we have there. Now from this point, you could enter in this entire calculation into your calculator. You need parentheses around the entire top, and then divide by negative 32. And let's recognize that there's two values here. There's the plus value here, and then the minus value in between. So let's do the plus one first. So in our calculator, I'm going to open up a set of parentheses, and that is negative 96 plus the square root 1024. Double close those parentheses and divide by negative 32. So one answer, that would be a t value of 2, and that's seconds. So 2 seconds after the ball is thrown, does it have a height of 228. So t equals 2 will satisfy this equation. Let's do the other one, the subtraction here. Negative 96, subtract that square root over negative 32. I'm going to use my entry feature, which is found by second enter. I can now manipulate and turn that to a subtraction. So I hit enter, and the answer is 4. So after 4 seconds, also a value here of 4 will make my height of the ball 228 feet. So that means it had that value on the way up and on the way down. So let's see. So we entered there, and there are my answers. 2 seconds or 4 seconds.